Alright, I am making a video on October 12th in attempts to save my voice and in anticipation that I hopefully will go home today. You're going to add to your notes on measuring location. The first heading after measuring location will be interpreting percentiles. Please get that down in your notes right there. The example I have is Mrs. Opal is concerned about how her daughter's height and weight compare with those of other girls her age. The doctor determines that the doctor determines that there's an error there. A doctor determines that her weight, it should read, is at the 14th percentile, so that her weight is at the 14th percentile, but her height is at the 70th percentile. So reread that. That looks bad. I'm sorry. Right in there. Okay. Her weight is at the 14th percentile, but her height is at the 70th percentile. Explain to someone who knows little statistics what this means. I have a sentence frame for you right here that I want you to pause and write down. What this means is blank percent of observations from that population are equal to or less than blank. How do I interpret that in context of this problem? I would say 70% of girls Mrs. Opal's daughter's age are equal to or less than her daughter's height for the height percentile. And then for the weight percentile, I would say only 14% of girls Mrs. Opal's daughter's age are equal to or less than her daughter's weight. The next heading I want you to get down is relative scores. I have a spelling error in here too. I'm really on fire today. Sorry, guys. Kevin Durant is 6 feet 9 inches, which is 81 inches. I think it should read Britney Griner is 6 feet 8 inches, which is 80 inches. Right now, you'll notice Kevin Durant is taller than Britney Griner. Next, we read, first, assume adult male heights are normally distributed with a mean of 70 inches and a standard deviation of 3 inches. Assume also that adult female heights are normally distributed with a mean of 64 inches and a standard deviation of 3 inches. Who is taller relative to their peers? This is a perfect place where a Z-score will fit. Remember, a Z-score is measuring how extreme an observation is compared to others in that population. What we're going to do first is we're going to find the Z-score for Kevin. Kevin's Z-score is 81 inches. Why am I using 81? Because the mean is in the mean is in inches. 81 inches minus, excuse the pen change there, minus 70. I'm going to put this in parentheses, and then I'm going to divide by 3. I'm going to plug that in my calculator, and I'm going to put parentheses in if I plug it in all at once. 81 minus 70 divided by 3 gives me a Z-score of 3.67. This is extreme. Remember yesterday we said anything above 2 or below -2 is considered an extreme observation if it's normally distributed. Next, we're going to find Britney's Z-score. Britney now will have a different mean, remember, because she's a woman. Britney's height is 80 inches. Minus the mean for females, which is 64 inches, divided by the standard deviation, which is 3 inches. Excuse me while I change my pen color so you can see. When I figure that out, 80 minus 64 divided by 3, Britney's Z-score is equal to 5.33. She is very extreme compared to her population. So it says, who is taller relative to her peers? That's going to be Britney. Why? Because her Z-score is more extreme. The last heading I have for you is finding raw scores. Sophia's standard score for the SAT math portion of the test was 1.6. Find her raw score if the distribution of scores for SAT math scores is symmetric with a mean of 500 and a standard deviation of 100. Remember, raw scores, or not remember, but let me tell you that raw scores is just finding the observation. When we find the observation, the first thing I want you to do is write down the Z-score formula. So Z is equal to your observation minus your mean divided by your standard deviation. So write down the Z-score formula. The next thing I want you to do is plug in what you know. We know that her Z-score was 1.6. Same thing as a standard score. Those are interchangeable. 1.6. We don't know her observation right here. We're going to call that X. We know her mean, which is 500, divided by her standard deviation of 100. Next, we're going to solve for X. I'm going to do this on the next page because I don't have a lot of room here. So if I have Z is equal to X minus 500 divided by 100, and forgive me, I need to erase something real quick. We know what her Z-score is. Her Z-score is 1.6. When you're solving for that Z-score, or for that observation, let me repeat. When you're solving for that observation, first you need to isolate X by multiplying by the standard deviation. What you do to one side, you do to the other. 1.6 times 100 is 160. Move that decimal over 2 to the right if you need. So we always multiply by the standard deviation first. And next, to isolate X, we're subtracting 500, so we need to add 500. We have 660 is equal to X. And that's our observation. That was her score on the SAT. Next, your to-do list is please do worksheet 1. I will be collecting this tomorrow. And then there's a Schoology quiz that should show up in your calendar or on the side that I want you to take to make sure that I know, so I know that you know what you're doing. Please take that as well by tomorrow. Again, when you're doing your homework today, follow these headings. I matched it up with your homework. It's bolded. So you'll see that in your homework. Let me know if you have any questions. I hope you paused throughout this, and we can talk more tomorrow.